So in previous lecture we have discussed what is meant by Newton's rings, how Newton's rings are formed. Now today in this lecture we will be discussing about expression for diameters of Newton's rings. So let us consider that there is a plane of convex lens having large radius of curvature is placed on a plain glass plate so that a wedge-shaped air film is formed between lower surface of the lens and upper surface of the glass plate. Now with this as a curvature, if you trace a circle, then radius of this circle is called as radius of curvature of the plane of convex lens. So this is nothing but this radius of curvature, that is r. Now let us consider that at any thickness t of the film, a Newton's ring is produced and therefore this distance is r minus t. Now in case of a wedge-shaped film, we know that path difference delta is equal to 2 mu t cos of r plus theta plus lambda by 2. This is the effective path difference in case of a wedge-shaped film, where mu is refractive index, t is thickness of the film, r is angle of refraction, theta is angle of wedge, lambda is the wavelength of light. Then you know that for normal incidence, angle of refraction r is 0. Then for large radius of curvature of the plane of convex lens, theta is nearly 0. And for air film, mu is equal to 1, that is for air. So we use these values in this equation and hence we get the equation for path difference as path difference is 2 times t plus lambda by 2. Now look at the geometry of this figure. Here if we apply Pythagoras theorem, then from the Pythagoras theorem we can write for r minus t square, r minus t whole thing square, plus if a Newton's ring is produced at this thickness t, then rho will, let us consider that this rho is nothing but it is the radius of Newton's ring, and therefore by applying Pythagoras theorem we have r minus t square plus rho square is equal to r square. So this is r square minus 2rt plus t square plus rho square is equal to r square. Cancelling this r square, we get this rho square is equal to 2 times rt minus t square. Now if you look at this expression, here this term includes 2 times r into t and this term is nothing but it is t square. So if we compare radius of curvature of the plane of convex lens with the thickness of the film, radius of curvature being very large as compared to the thickness of the film, so this t square can be neglected and hence we can write rho square is equal to twice rt or t is equal to rho square upon twice r. So using this value of t, which is rho square upon twice r, in this equation we can have the path difference, equation for path difference as 2 times t is rho square upon twice r plus lambda by 2. So this 2 goes off and hence path difference delta will be equal to rho square upon r plus lambda by 2. Now we have to derive expression for diameters of Newton rings. So first we will derive the expression for diameter of dark rings and then we will derive the expression for diameters of bright rings. Now, as we know, the part difference is rho square upon r plus lambda by 2. This is the part difference. In case of this wave-shaped film, where this rho is the radius of Newton's ring. Now, as we want to derive the expression for diameter of dark ring, so we have to equate this part difference to twice n plus 1 lambda by 2, because if we equate part difference to odd integral multiple of half the wavelength, then it becomes the condition of minima, or it becomes the condition for destructive interference or darkness. And hence we have rho square by r is equal to, if I transfer this lambda by 2 on the right hand side, then it will be only n lambda. Now, as rho is the radius of Newton's ring, so I put a suffix n indicating that it is the radius of any nth dark ring. So, as rho n is nothing but it is dn by 2, where dn is diameter of any nth dark ring, and hence we can write for dn square upon 4r is equal to n into lambda. So dn square is equal to 4 nr lambda, or dn is equal to square root of 4 nr lambda, and hence dn is directly proportional to square root of n, where this n can take values like 1, 2, 3 and so on. And hence diameters of dark rings in Newton's rings are always proportional to square root of natural numbers. Then, in a similar way, we have to derive the expression for diameter of bright rings. So, expression for diameters of bright rings in Newton's rings experiment. So now we know the part difference, which is rho square by r plus lambda by 2. Now, as we want to derive the expression for diameter of bright rings, so we have to equate this part difference to integral multiple of wavelength lambda. That is, whenever this part difference is equal to integral multiple of wavelength, then it satisfies the condition for constructive interference or condition for brightness. And here, as this rho is nothing but it is the radius of Newton's ring, but as we equate this part difference to integral multiple of wavelength lambda in order to satisfy condition for constructive interference, so I put a suffix n indicating that this rho n is nothing but it is the radius of any nth bright ring. So we have rho n square upon r is equal to, if I transfer this lambda by 2 on the right hand side, then it will be 2n minus 1 lambda by 2. But as you know that rho n is nothing but it is dn by 2, where dn is diameter of any nth bright ring, and hence we can write this expression in terms of diameter of bright rings as dn square upon 4r is equal to 2n minus 1 lambda by 2, or dn square is equal to 4 times r into 2n minus 1 lambda by 2, 2 goes off, hence dn square is equal to 2 times r into lambda into 2n minus 1, or dn is equal to square root of 2r lambda into square root of 2n minus 1. Since this 2 times r into lambda is a constant, where r is radius of curvature of the plane of convex lens, it is constant. Lambda is the wavelength of monochromatic source of light, it is also constant. And hence diameter of bright rings are always proportional to square root of twice n minus 1, where this n can take values like 1, 2, 3 and so on. If we substitute these values of n, then the diameters of bright rings are always proportional to the values like 1, 3, 5, 7 and so on, it means that the diameters of bright rings in Newton rings are always proportional to square root of odd natural numbers. Hence, remember this thing that diameters of dark rings in Newton ring experiment are always proportional to square root of natural numbers, while diameters of bright rings in Newton's ring experiment are always proportional to square root of odd natural numbers.